Hello, my name is Silvia Almagia. I am technical expert within ETSI Center for Testing and Interoperability. I'm very happy to be sharing this talk today with Pierre Lynch from Keysight Technologies. We're going to be talking about how the ETSI NFV Plugtests are helping to measure and track the NFV evolution. So first of all, a little bit of context for those who are not familiar with ETSI Plugtests. These go well beyond interoperability events. ETSI is running this for a wide range of different technologies. And the idea here is to provide some neutral and coordinated framework for participants to join and run some collaborative testing validation activities with peers from different organizations. So in addition to this continuous platform, we also try to have some periodic face-to-face or lately remote events. ETSI does not certify or endorse participating companies or products, but we do provide the framework, the means, the methodology, procedures, test plans, test tools, the venue, coffee, everything what's needed for our participants to meet and perform the actual testing in a collaborative way. The main goals from ETSI perspective are to foster interoperability and to gather feedback in order to validate and improve the quality of our specifications. Participation is free and open to any organization providing something to test or to support the testing. So a little bit of history about the NAV Practice Program. These activities started 5 years ago with a very first experimental interoperability testing event. And since then, the scope has been growing and the testing has been getting more and more formal. So we added to the scope NFV API conformance testing, and also we've been adding to the scope some multi-access edge computing, interoperability, and API testing lately. The last event we had was the NFV&MEC API Plugtests last February. This was run remotely for 1 month. And actually, this talk is going to be a lot about what we learned and what we saw during this event. Also, we are starting to prepare for a second event this year. This will be in October, and this time we'll be looking for NFV&MEC interoperability testing. The two main enablers for the Plugtests activities are Hive and TAP. You know, we love acronyms at ETSI. So Hive is the hub for interoperability and validation at ETSI. It's a big network, a big VPN network where participants can connect their implementations, can connect their labs, can expose their APIs in order to run the sessions with other participants or to get their APIs tested for conformance. The other enable is TAP, the test automation platform. So this is a test system that we have deployed on the Hive, on this network. The idea here is that participants can connect and actually run the testing on their APIs. The APIs are exposing on Hive. They can select which test suites they want to run. They can configure them. They can run the whole or just one by one. They are completely autonomous, but of course, they can request help and support from the Plugtest team whenever they need. So this is what we've been using during the month of February, and participants could choose when they wanted to connect on what they wanted to test all through this month. In terms of scope for this event we just ran in February, we were looking at, as I said before, at NFV&MEC API conformance testing. So for NFV, we were mainly looking at SOL 2, SOL 3, and SOL 5 specifications, which are the ones describing the APIs exposed by the Mano components and by the VNFs themselves. So for these API specifications, ETSI NFV developed some open APIs definitions that are available for implementers to be used to develop the APIs. And also in parallel, the TST working group that Pierre is leading is working on test specifications. For NFV, this is called TST10. And this is covering all the APIs defined by NFV. For the to go with the test specifications, we have some robot test suites that allow to automate this testing. And these robot test suites are the ones we plug in the TAP, in the test automation platform, so that participants can access them, execute them, and get their APIs tested. All these specifications, open APIs, test specs, and robot framework are available for download in the ETSI site or in the ETSI Forge, which is our GitLab repository. In addition to the API testing, we also had a couple of additional tracks led by supporting open source communities. So the first one was led by the ETSI open source Mano community. It was to help VNF providers to get their OSM legacy descriptors upgraded to NFV-SOL 6, which is the standardized model for young descriptors. The second one was led by the Cloud Native Computing Foundation. This was to allow CNF providers to self-assess the level of compliance of their network functions with the cloud native principles that CNCF is defining. In terms of participation, we had a wide range of companies and open source communities engaged. So participating to the API testing, we had 4 VNF managers and 10 NFV orchestrators and 2 MEC platforms and services providers. But also participating to the additional tracks and supporting the testing and providing the test environments, we had 7 VNFs, 6 platforms based on Kubernetes, OpenStack, Linux, several test tools, 5 supporting open source communities, as I mentioned, and several operators and universities joining as observers and participating to the different discussions on the findings during the plug test. And we also have some companies joining to provide technical support and reinforce the plug test team so that we were ready to help our participants whenever they needed help, wherever they were on any time zone or location. So with this, I'm going to hand it over to Pierre, who's going to walk us through the different results and findings and learnings that happened during this event in February. So all over to you, Pierre.
Thank you, Sylvia. My name is Pierre Lynch. I'm lead technologist with Keysight Technologies, but more importantly for this presentation, I'm the TST working group chair at ETSI NFV. And I also am rapporteur for the TST10 work item that Sylvia briefly mentioned earlier. I'm going to present the results part of the plug test. As usual, testing gives us a reality check of where we are, and it allows us to measure the progress we have towards the evolution of NFV. So I'll start with giving overall results, and I'll start drilling down per reference point and then per API as well to give you a better view. All of these results are contained in the plug test report. So as a start, the overall results, meaning all the tests that have been run, so it's almost 1,200 test cases with 14 companies participating with NFVOs and BNFMs. This is a good result in the sense that a lot of tests were run. Don't be alarmed by the 50% pass rate or approximately. It's still a good sign that you want to fail fast, fail early. So it gives people, the companies that participated, good feedback on what's going on and how their progress is going. So any results, any testing is always a good result. So moving on here towards the actual reference point. So this is results per reference point. So SOL 2, as a reminder, is the reference point between the VNF manager and the VNF itself. SOL 3 is the reference point between the orchestrator and VNFM, while the SOL 5 is the northbound interface or reference point from the orchestrator towards the OSS BSS. You'll notice that a lot more testing happened on SOL 5 than the other two. The SOL 3 has almost a little over a half of the participation, while SOL 2 has a little bit less participation. Moving on again, this gives the results per version of the specifications that has been tested. First thing to notice is everything is release 2. So versions 2.4.1, 2.6.1, and 2.7.1 were used. 2.7.1 was only used in SOL 5, while as 2.6.1 was the most popular one in both SOL 5, SOL 3, and also SOL 2. So the progress seems to be going a little bit faster on the orchestrator as far as new specifications are involved. Now, on a per system under test or function under test basis, the orchestrator, again, was the most popular choice. Now, that's true because we had 10 participating companies with orchestrators versus 4 with VNF managers. But the pass rates are all largely the same. It's all about 50% pass rate versus fail rate. And again, I don't get alarmed because of the 50%. It does mean good progress. It means people are implementing these APIs. We just need to progress a little bit more, and this will give them the feedback that they need in order to do that. Now, drilling down a little bit further into the results, this slide shows the results on a per API basis, classified on a reference point basis. So starting from top left, going clockwise, SOL 2 VNFM, meaning VNFM is under test. SOL 2 is the reference point between the VNF and the VNFM. Only 16 test cases were tried there, and they were all on one side. So there should be a VNF category here, but there isn't. So that, again, is one of my concerns. No VNFs were tested for SOL 2. And even for VNFM, it was just a handful of test cases. Hopefully that'll improve for the next plug test. Now going top right, this is the SOL 3 interface, reference point between VNFM and NFV-SOL. Now, quite a few more test cases here were run, so 220 approximately, with approximately the same pass rate as the overall pass rate, so close to 50%. Only 2 APIs were tried here. Lifecycle management being the most popular, that's a good thing, and it's natural that it is being implemented first. Bottom right, this again, SOL 3, this time the NFV-SOL under test. 3 APIs were tested there, package management being the leader and most popular one. And again, it's natural that that one be implemented first because it's necessary for onboarding. And it also had quite a few test cases, so over 200 and a little bit higher pass rate as well. So that's a good sign. Now, bottom left, SOL 5, that's the reference point between the orchestrator and the OSS BSS. That one is the most popular by far, over 700 test cases run. Pass rate approximately the same all over as the overall pass rate. Lifecycle management and also NSD management, which is a good sign, are the ones that were the most tested. So those are the first APIs that seem to have been implemented. Now, for all of these reference points, not all the APIs were tested. Hopefully, again, that'll be improved. But it's a good thing that these guys have been implemented, and now they get feedback on their implementation, which should help them accelerate. What have we learned from this exercise? First of all, the feedback was there's a potential inconsistency on the disk and container format as specified in the solution's SOL specifications, where in the specs, everything is specified in uppercase, but there's references to OpenStack documents or documentation that has everything in lowercase. So this has been brought back to the SOL working group. They'll take a look and see if this needs to be fixed or not. Next, there was a usability issue on hard-coded authorization header. What this is the specification said that the header should be authorization. However, some implementations aren't up to spec for that one particular issue, and they were using different authorization headers. The spec itself needs to be authorization, but it was requested and brought to the TST working group for test 10, which are the test suites themselves. Could we be more flexible? The TST working group agreed, and we allow now the configuration of that authorization header to be something else to allow people to do the testing without that specific authorization method. This is a flexibility, and the test working group said, hey, why not? We'll just allow that. However, in order to be conformant to the specification, the header must be authorization, and the document has a disclaimer saying that as well. And lastly, and much to my happiness, is there was tons of feedback on the TST10 test suites themselves. This is great. Like any tester, I'm happy to see feedback and issues corrected before they hit the field, especially for 2.7.1, which is the version that's under construction right now, soon to be published. But I always love that we've tested it, we found bugs, we fixed them. They should be very mature by this time. Other things that happened during the plug test, and this I'm very excited about, is there was an intense collaboration with CNCF, so the Cloud Native Computing Foundation. The plug test, the ETSI plug tests have always had a lot of collaboration with open source in the past, either OPNFV, OpenStack, OSM, ETSI, and this continues on, and I'm always happy to see this. So in this case, CNCF came in and they use their own test suite in their environment, or the participant could use their own Kubernetes cluster. But the point was to test containers, okay, in this environment. Now, this is work that's ongoing at ETSI NFV to include the ability to have containers versus VMs for VNFs. So this is a great first step. This was an experimental track. So only 4 participants took part, and we didn't collect results or report results based on this. This was just people trying it out to see how things work. So it was a first step, and it provided feedback to CNCF on their own test suite. So this is valuable stuff, and it shows the collaboration between standards and open source is alive and well, and that always makes me happy. Furthermore, there was an activity that started that took a look at EVE 11, which is a document produced by ETSI NFV, which looks at the specification of the classification of cloud native DNF implementation. So it's the original requirements of how to bring cloud native into ETSI NFV architecture. And they took a look at the tests themselves and what they're testing for versus the requirements specified in EVE 11. So they could do a little bit of a comparison and see, are there gaps? And for most of things were aligned, which is a great sign. But there are 3 things where they were not aligned so far. So security and observability were not defined in EVE 11, but were defined in CNCF test suite. But load balancing, on the other hand, was defined in EVE 11 as a requirement, but not tested in CNCF. Now, security kind of sort of makes sense because that's always addressed in stage 3 at ETSI NFV, so that will likely be addressed when the APIs are defined in the current activity of allowing containers and cloud native functions to become part of the ETSI NFV architecture. So I'm not too worried about that. This was an important first step. I think this will continue on into the next plug test, and I love seeing this collaboration. So the takeaways, what did we get out of this? So the implementation of the APIs is well underway. It's a great sign. They're not perfect yet, and the pass rate shows that, but it's an important first step towards that. And not actually first step, but it's an important step towards that end to be able to implement these APIs. The pass rate is not the only point. We shouldn't take too much weight to that. It's the fact that they're being implemented and now they've gotten feedback. One point of concern that I do have is SOL 2, and especially from the VNF side, I wish that would increase and people would test and implement those APIs. But hopefully that will improve for the next plug test. Secondly, I'm so happy we got a lot of bugs found and corrected in the test 10 suites. So that's always a good thing. And collaboration continues with open source. And in this case, we brought in CNCF. They came in and just helped us along the way. And this is a collaboration that will be going on for the future as well. The report is ready. A link is provided there. Please download it. You'll see these same results, but with far more detail in it concerning the results themselves and also the setup that Sylvia described previously. And then stay tuned. In October, there will be yet another plug test. This one will focus much more on interoperability, which is a normal thing for a plug test, but these APIs will be tested as well. The current thought and hope, we're all crossing our fingers, is that it may be face-to-face. If not, it will be remote, because we know we can do that successfully, as proven by the last few plug tests. If you have any questions, please do not hesitate. Send an email to Sylvia or to me, and we'll do everything we can to answer. Thank you very much for your attention. Have a great day.